You may begin, Karabo.
Thank you. All right. Good morning, grade sixes. Welcome to yet a beautiful day. Welcome to the STEM Lockdown Digital School. You are tuned in for Natural Science grade 6. Just to remind you who I am, I go by Karabo Khashani. On Instagram, I go by KB_Khashani, and on Facebook, Karabo Fiona Khashani. It is always a pleasure having you guys, and thank you so much for tuning in. And without wasting any more time, we're going to get straight into it, all right? Please remember to just keep the chat only related to relevant questions. Avoid, chatting to each other or amongst each other. Let's just use the platform to ask questions because I don't want to miss any relevant questions. All right, so please do remember that, and let's go. All right, so we're going to do just a quick recap. If you joined us in yesterday's lesson, we spoke about mains electricity, coal, oil, and natural gases, and we also discussed the formation of fossil fuels. All right, how fossil fuels came about and their importance, as well as coal and what it is that we actually use coal for. All right. All right, so yesterday I actually gave you some homework and you were required to find the meanings for the vocabulary that I gave you. Who actually did it? Who did the vocabulary that you were required to do yesterday? Anybody? Right, I see a lot of you saying me. Awesome. Thank you so much for doing your work, guys. All right, we're going to go just over the words now, just to make sure that you've got the right definition. Remember, our words will not be exactly the same because we may have gotten them from different resources and we obviously may have used different textbooks. All right, so here's what I've got, and you're more than welcome to just add or actually share with me what you also have. All right, so fossil fuels, basically this is a natural fuel such as coal or gas formed in the geological past from the remains of living organisms. All right, that's what fossil fuels are. Right, then we've got coal. Coal is a hard black substance that is dug from the earth in pieces and can be burned to produce heat or power. All right, so you're more than welcome to add on what you have because, like I said already, our meanings may not be the same. Right, then oil. Oil is a smooth, thick liquid that is used as fuel and for making the parts of machines move smoothly. All right, oil is found underground, usually just a very thick black liquid. All right. All right, natural gas. A natural gas is like all fossil fuels. It is a non-renewable source of energy formed in the earth over millions of years. All right, it is the earth's cleanest fossil fuel. It is colorless and odorless, meaning it doesn't have a smell when it's in its natural state. So when it hasn't been processed, so in its natural state, it is colorless and odorless. All right, a power station. A power station is an industrial facility for the generation of electric power. So this is the area where we rely on our electricity and where we expect to get our electricity from power stations. All right. All right, Matlodi, I will just give you some time to copy. You remember it is going to be just a bit hard to copy word for word because we are working with time, but I'll definitely give you some time just to copy that down. So yeah. All right. A turbine. A turbine is a rotary mechanical device that extracts energy from a fluid flow and converts it into useful work. All right, so this is just a device. If you tuned in previous lessons, we spoke about what a device is. All right, so basically, a device works to extract energy from a fluid flow and converts it into useful work. Zamiel, you've got your hand up.
Fossil fuels
I would a fruits such as coal are a natural gas from in the earth from plant or animal remains.
All right, that's excellent. Very good. Correct. Thank you, Zamil. All right, very good, Zamil. That is 100%. Right, remains of old organisms, animals, and plants. All right. Right, then we've got a generator. A generator is a device that converts motive power into electrical power to use it in an external circuit. We spoke about circuits previously, all right? And obviously now if there is no power coming from our power mains, our electricity mains, there are people that rely on generators. Many stores, grocery stores use generators in case there's a power failure. And maybe some of you actually do have generators in your homes. If there's a power failure, you're relying on that to just supply you with energy for the time being. Any of you've got generators at home, actually? Who's got generators at home? Right, Sean Gordon's got a generator, awesome stuff. All right, so does JD, Kanya, Tristan, Abu, 5 generators? Sure, that's a lot, if that's what you mean. All right, cool. Matlodi says, no, ma'am, generators are expensive. I agree, extremely expensive to get a generator. All right. Adele says a very small one. Kaylee has a generator. All right, thank you for that, guys. All right, I don't have a generator. So when there's no electricity, I'm in the dark until it comes back. That is me. All right, I don't know about you guys, but I rely on my torches and portable lights that I've got. I do not have a generator, right? But for those of you who do have, that's very, very lucky. That's really, really nice. All right. Renewable, this is a resource which can be used repeatedly and replaced naturally. All right, so it can be used over and over again. And then lastly, we've got non-renewable. This is a resource that cannot be readily replaced by natural means at a quick enough pace to keep up with the consumption. So this is just basically the opposite of non-renewable. It cannot be replaced as quick as we consume it. I'm literally just going to give you 30 seconds for those who are still copying down, and we will carry on. 30 seconds starts now. There was a 1 more minute. Oh my goodness. I'll give you 40 seconds. All right. And I can always just come back to it. All right, moving on. Yes, Mokana says you can take a screenshot. There we go. Perfect idea. All right, and moving on. All right, so today at the end of this lesson, you are expected to know where electricity comes from. Just also, just going to touch on some fossil fuels and why do we save energy and how can we do it? And why are illegal electrical connections so dangerous, and what is the difference between renewable and non-renewable? Just like I said yesterday, this is going to be a continuation lesson, so you need to obviously be in every lesson to understand where we are going. So every day we are moving on onto new topics, but related to electricity and fossil fuels, all right, and energy. All right, now the main supplier of electricity in South Africa is Eskom. All right, now Eskom does not have any competition. All right, it's a company that supplies us with electricity, and when they are down, the entire South Africa is down. So when you guys are older, maybe you guys should consider, opening up your own little Eskom. All right, just in case when Eskom is down, at least you can pick up. Hey, how about that? All right. Basically, it is the main supplier. So we rely on Eskom to supply us with electricity. All right. And who can maybe give me the term for a business or a company that is the only one. It doesn't have any competition. All right, it is the only one in the country. All right, so something like Vodacom has competition like MTN and Cell C, but what about Eskom? What do we call those companies? That's just something out of the ordinary. For someone who actually knows. Oh my goodness, and Jackie said monopoly. Very good, Jackie De Silva. Thank you so much. You're 100% correct. It is called the monopoly. Yay! Awesome stuff. All right. Now, Eskom uses mainly coal to produce energy for industrial and household use. So we rely on Eskom for our own household use and industries. Lots of businesses rely on Eskom. So we're just basically going to look at the steps as to how electricity is actually made from coal. All right, so first of all, coal is transported from a coal mine to a power station. All right. So from a power station, coal is transported. All right. Then at the power station, the coal is grounded into fine powder, right? It's called pulverized. So the coal then, like just as much as if you had to make I'm trying to think of something, like if you're trying to make crushed biscuits or making a cream cheesecake, you would need to take the biscuits and crush them into small powder. So that's what happens with the coal. It is grounded into very, very fine powder. The grounded coal then goes into a container where it is burned. All right. The heat generated from the burning coal is used to boil water in a huge boiler. All right. And then the boiling water produces steam that turns a turbine, which we just did previously. Now, obviously, a turbine is just a very big wheel that turns. All right. And then the turbine is linked to a generator, which is used as coil to produce energy. All right. So basically, it starts off with just having these big chunks of coal. Eventually, they are then crushed into very fine powder, put into a boiler, and in that way, it gets burned to actually produce us with the energy that we need. All right, now from the generator, the electric current is transported, or rather carried by a system of electrical transmission lines, which are also called power lines, which you would always see at mains electricity, power lines hanging towards very, very large power stations. All right, and that's what we rely on to supply us with electricity. All right, and I see Dr. Carl Johnson saying that my uncle works at Eskom in Cape Town. All right, that is very, very interesting. All right. All right. We can always just come back to the slides. And remember, you cannot copy word for word. You're just going to have to take down notes of the very important points that I've mentioned. All right, moving on. All right, so this is basically just the process. So basically what I just spoke about in the previous slide, here's just a picture to show you, just for a big understanding. As you can see now, this is the coal mine. Chunks and chunks of coal would be over here, and it is then grounded into very, very small powders. All right, so it is pulverized into very, very small powders into the boiler. As you can see, it's releasing steam. We actually see a lot of this steam coming out. If a lot of you know an area called just by Kempton Park, there are huge boilers, and there are times where you actually see steam coming out of them. Now you can imagine the kind of pollution that happens. All right. So that's just a breakdown of what exactly happens from the actual coal mine right until it reaches our home. All right. Right, Jackie says Sebenza. You are 100% Sebenza. Right. For those of you in Cape Town, actually, there is, I don't know about Cape Town, but yes, in Gauteng, there is huge power stations just by Sebenza. Large boilers, massive, very massive. I'll show you a picture in the next lesson, actually. And I'll actually see if there are actually any in Cape Town as well. All right. All right, fossil fuels. Now, did you know The burning of coal produces billions of carbon dioxide each year. Now, carbon dioxide is one of the greenhouse gases that contributes to global warming. All right. Now, fossil fuels are non-renewable resource of energy. This is because they take millions of years to form. Once these fuels are burnt, they cannot be recovered or reused. They are non-renewable. People on Earth are using up to these deposits of fossil fuels much faster than they are being made, as they take millions of years to be made. So as humans, we're actually consuming so much of these deposits, and we're consuming them at a pace that it's taking way longer for them to actually be made. So we are consuming them way too fast. All right. All right, now a power station releases smoke that is given off when the coal is burnt. All right, so as you can see in the picture below, that is a whole lot of smoke that has been given off, and smoke that is actually going into our, into our air, which contributes a lot to global warming, right? And that is obviously what we call air pollution. But, the downside is that we do need electricity for survival. I mean, a couple of days ago, I actually asked some of you, how would life be without electricity? Imagine how devastating it would be. Some of you said would be really, really hard. You wouldn't be able to play games on your phone because you can't charge your phone. All right. So it would have been really, really hard without electricity. So we do rely on coal to provide us with the energy that we need. All right. This causes huge environmental concerns as it is polluting our atmosphere. So like I said already, our atmosphere relies so much and obviously gets damaged so much by the coal that we're burning, and it is polluting our atmosphere. All right, now let's discuss the cost of electricity. Now, do any of you have any idea, especially for those of you who use prepaid electricity, just out of, how much do you think your household, the home that you live in, how much do you think your family spends on electricity a month? Does anybody know? Tristan says 10,000 a month, or is this a year? All right, how much do you think your home spends on electricity? How much are your parents buying? Malanda says 300. All right, Tristan says 10,000 a month. That's a lot of money. All right, then I've got someone here saying 5,000. Iksan saying 300 a month. All right. Talia, 20,000 on electricity. Zamil, 300. SG says 5,000 and Dovu 800. All right, so obviously now it's going to depend with each and every single household, right? If you've got a bigger home with with a lot of lights and a lot of electrical appliances, it is going to consume a whole lot of electricity. All right, now your prices that you guys bring up, it's a whole lot. All right, 16,000. Are these figures you're giving me a year? Is it a month? Is it a week? Gona says 1,000 a month. All right, reasonable. All right, reasonable. And obviously, it's very, very different from every household. Now, do you hear your parents and other adults talk about the cost of living? Now, do they remind you to switch off your lights and other appliances that are not in use? Now, electricity is a very, very expensive resource. In my home, I always make sure that I switch off the plugs that I'm not using, that the microwave is off, that I don't charge my phone excessively. If I'm not in a specific room, I would switch off those lights just so that I don't spend so much on electricity. All right. Now, electricity is extremely, extremely expensive. And for families who are spending, like some of you say, 20,000, 10,000, that is a lot of money on electricity, right? Now, I need you guys to tell me then, how can that be avoided? How can you avoid spending 20,000, 5,000, 16,000? How can it be avoided from spending so much money? All right, especially because, it's a lot of money, and yes, we need electricity, but how can that be avoided? All right. All right. Tristan is saying save more electricity. All right. All right. All right. All right. So I want you to tell me now, how can we avoid all of that? Yes, Abu. Abu, are you there? Nope. All right. Luandle.
Ma'am, I think we can avoid, like, we can save electricity by switching off the plugs that we are not using.
Excellent. 100%. Of course. By switching off the plugs that you're not using will help to save electricity. All right. A lot of you are saying budget for everything. All right. That's very good. Budgeting. By switching off appliances and lights that you're not using, turn off electrical devices or appliances when not in use. All right, so a lot of you actually have an idea as to how we can use less electricity. All right, excellent. So now you can tell me, why do you think electricity is expensive? Why is it even so expensive? Why is electricity expensive? Zamili, do you want to answer me as to why is it expensive?
It's part of the
Yes.
pipeline. One,
It's because it's expensive
one
because
step
hard
there
to
is
make.
running the unit test. If the unit
All
test
right,
fails,
I
the
heard you. I think I'm hearing your guardian or dad more than I can hear you. But yes, because it's much more expensive to make and obviously very, very hard. All right, Luanzi, you got your hand up again. Why is it expensive?
Because there's a high demand.
Mm-hmm. All right, that is a very good word because there's a high demand. Then I've got somebody, I've got no idea, but I will unmute you. What is your name and why is electricity expensive?
Ma'am, my name is Aletu, ma'am, and electricity is expensive because some people use it more than we do, and that increases the cost that they have to pay.
Interesting. Thank you, Oletu. Thank you so much for that. All right, awesome. Adele, you had your hand up. No, no, it was Kaylee. Sorry, Kaylee. Yes.
Ma'am, it is expensive because coal is a non-renewable source.
Excellent answers. Oh, sorry. Yes, and carry on.
No, ma'am, never mind.
All right, cool. Thank you. All right, because it is a non-renewable resource, 100%. All right, and I see some of you saying that because we use fuel that takes lots of years to form. Very good. Malande saying because it costs to generate. All right, 100%. All right, very, very good. All right, so it is expensive because the infrastructure required to deliver and produce electricity is costly. I mean, you can imagine all these machines and turbines and generators and this and that. All of that is all very, very expensive infrastructure, and they obviously need to be maintained. I mean, you can imagine, you know, if mom or dad or sister has a car, that car has to be taken to service every day so that it works well. I'm sorry, not every day, but after specific kilometers, that car has to be taken for service. That is a cost on its own, just to check that the car is still running, everything is still okay. So even with power stations, all of those machines have to be maintained to check that they are still working well. The infrastructure refers to the coal mines, the trucks, the power stations, the substation, the wiring, and the employment of labor. The people that are actually digging out the coal and working in power stations have to be paid. For example, I think it was Dr. Carl R. Johnson in the chat said that the uncle works at Eskom at the power station. Now, he needs to be paid. Now, we obviously have to pay for that. All right, we need to pay for labor. Now, all the buildings, vehicles, materials, and processes have to be maintained continually, and this costs money. If we do not maintain our infrastructure, we simply won't have enough electricity. If mom or dad does not take their car for service, it will eventually break down. All right. So it is very, very important to keep our power stations well maintained? All right. All right, Jackie. See you tomorrow. Goodbye. Now, some appliances use a lot more energy than others. For example, a geyser uses a lot of electricity to heat the water. Now, I want you to think about your own home, where you are right now, and what do you think uses up the most electricity in your household? What uses up the most electricity in your household? Zamili says the TV. Kanya, the lights. All right. Okay, keep your answers coming in. What uses up the most electricity? Ndovo, appliances and lights. Tristan, lights, plugs, stove and the geyser. TV lights. All right, cool. Tiago, the TV. Larato, lights. Tando, TV. Okay. Now, most homes today have prepaid electrical meters installed. In older homes, though, a worker from a council will come and read the meter to ascertain how much electricity your household has used. Now, electricity is expensive, and the more electricity we use, the more we pay, and the more fossil fuels we use up. All right, so we need to realize that the more we are using in our homes, the more we are going to pay. All right, and that is more fossil fuels that we are burning up. Simeka says the geyser. All right, so all of you are telling me about all these appliances that are using so much electricity. In my home, actually, I have no idea what could it be. I think could be the washing machine, right? That uses up a lot of electricity, right? So basically, we need to realize that the more we use, the more we are actually paying. Now, I know with a few of my family members, they basically use up electricity, and then every month they get a bill sent to their post box or their email, and they have to pay what is on the bill. And then there are some homes that use prepaid, where you just have a voucher and then you enter that in. So who of you have prepaid, and who of you have, get a bill sent where, month end, a letter comes saying that you've spent 3,000 Rand and you must pay it. All right. So just tell me who of you. All right. Tristan says we get a bill sent. All right, cool. So with Tristan, they use electricity, and then every month they get the bill. Larato is prepaid. Abu, there's a bill. Ndovu prepaid. SG prepaid. Simeka prepaid. All right, cool. Most of you prepaid. Sibile says a bill. All right, interesting. I use prepaid. All right, so that I can see, so that I don't go over my specific budgets. All right. All right. A lot of you are saying prepaid. Carl Johnson, sorry, says a bill. Talia, they get a bill. All right, cool, guys. Awesome. Let's move on. All right, now let's discuss measurements of electricity. So how can we actually measure electricity? This is my favorite part. You guys are going to really enjoy it. All right, so electricity is measured in kilowatts. All right, now kilowatts. If you look, well, okay, let me not rush it. We'll go step by step. Very exciting part. I love this. All right. Now, 1 kilowatt is equal to 1,000 watts. We're going to do a bit of math today. All right. So bear with me. So 1 kilowatt is equal to 1,000 watts. Now we can calculate the cost of running a household appliance using wattage. Now we're going to use this formula to estimate an appliance's energy use. I need you guys to listen very, very carefully, because you're going to have some homework to do. Okay. So listen. So first of all, I would suggest you write down this formula, please. Wattage times hours used per day divided by 1,000 will equal to daily kilowatts an hour. I'm going to break it down for you step by step, so do not worry. Just write down that formula, please. All right, now kilowatt consumption. So we basically multiply this by the number of days you use the appliance during the year for the annual consumption in kilowatts per year. I know it sounds like a lot, but we are gonna do an example together, so don't worry. All right. Now here's an example of the annual electricity consumption of a personal computer, a laptop. Now first of all, depending on your laptop, but a laptop could be 120 watts. Usually at the back of the laptop or at the back of your kettle, there's a small little label that specifies how much watts the appliance uses. Now, for a laptop, we've got 120 watts. Now, 4 hours a day, meaning, you know, this laptop is used for about 4 hours a day. So we times the watts with how many hours a day and by the days to make a full year to find out how much we use in a full year. Oops, sorry. And according to this, about 394 kilowatts are utilized a year with the laptop. All right, but let's get a bit more practical. All right, have a look at this over here. All right, we have got a radio clock, a clock radio. Basically, it's on throughout the day because it shows the time. And this clock uses 10 watts. Now, we are going to find out how many kilowatts does it actually use up the whole year. So first thing that we would need to do is we're going to say 10 watts times 24 hours because it is on the whole day. The fact that that time is on there shows that that is something that is used the entire day because I don't switch it off when I go to work. I keep it on, right? So it's 24 hours a day. So I times 10. 10 times 24 will give you 240 watts a day. So each and every single day, I'm using 240 watts a day. Now remember, I want to find out how much I'm using throughout the entire year. All right, so I'm going to times that by 365 days. Are you all following with me so far? Stop me if you are confused. Remember, this radio clock uses 10 watts, and because I keep it on the entire day, it is 24 hours. All right, 10 times 24 gives me 240 hours a day. Now, because I want to use it, I use it up the whole year. 240 times 365 would give me 8,700 watts. Now remember, I want kilowatts. I divide it by 1,000. It gives me 876 kilowatts that I am using the whole year. All right. That is basically how you calculate kilowatts. Now we're going to try and do, in fact, I want you to try and do the tumble dryer. I want you to use 3,000 watts. And I use this tumble dryer for 2 hours a day. Let's say I use this tumble dryer every day for 2 hours. So I want you to please give me the answer that you get for the tumble dryer. So find your calculators wherever you are, get your calculators, use the formula that we did for the clock radio to find out how many kilowatts are used for the tumble dryer. I'm going to give you a minute. I'm going to give you a minute for that. Tristan 6,000, Iksan 6,000, Simega 6,000. Okay. Let's just give others just a couple more time. Zamili, your hand is up.
I don't understand. How is it 10 watts?
All right, I'll answer you. All right, so how is it 10 watts? Because usually at the back, I don't decide how many watts an appliance has. At the back of an appliance, it just says 10 watts. Right, so now if you, I don't know if you're close to a kettle, maybe where you are, Zamili, you can actually look at the back of the kettle and you'll see that it's actually specified how many watts the kettle uses. All right, so that is basically the actual number of watts that a specific appliance uses. All right, Kaylee. Kaylee, are you there? All right, no luck from Kaylee. All right, a lot of you are saying 6,000. All right, let us find out. So 3,000 times 2 hours, so 3,000 times 2 equals 6,000 watts. Now remember, I want the answer in kilowatts, don't forget. All right, I'm going to times it by 365 to get how much I'm using the whole year. Remember that. I want to find out how much I'm using the entire year. Okay, don't forget that. The entire year. So I get 6,000 times 365 days. I get 2,190 watts. Divided by 1,000, I get 2,190 kilowatts. A lot of you stopped at just per day, but you are right. Every day you are, so you guys are correct. Every day you are using 6,000 watts. Right, a lot of you said 6,000, very, very good. Every day you are using 6,000 watts. But I want you to tell me, how much are you using the whole year? And that's why you times it by 365. All right. But a lot of you, very, very good. Thank you so much for your answers. Novel 2190. Excellent. Let's do the last one. A microwave. It's 900 watts for 6 hours. But tell me, how much am I using the whole year? How many kilowatts am I using the entire year? Use the previous steps to get your answer. I'll give you a couple seconds for that. All right, Iksan saying 5,400 per day and 1,971 kilowatts a year. Okay, we'll find out. Malande 1971. All right. Abu, your hand is up. No? Okay. All right. 197. All right, let us find out. So what we're going to do, 900 times 6 hours, we get 5,400. All right, that's how much we're using every day. We're going to times that by 365 days to find out how much we're using the whole year. We get 1,971,000, but we divide it by 1,000 to get kilowatts, and you are correct. 1,971 kilowatts is what we are using a year. Well done, guys. Excellent stuff. Kamo, your hand is up. Nope, nothing from Kamo. JD.
Ma'am, how do you get the watts?
Sorry?
How do you get the watts?
So you will always be given the watt. Like as you can see on these pictures, I've given you the watts. The radio clock uses 10 watts, so the watts will always be given to you. A tumble dryer uses between 1,800 to 5,000 watts. So I've decided that we use 3,000 watts. So the watts will always be given to you all the time. It's always at the back of an appliance. So we are going to get into that tomorrow because of time. So let me just see where we are on the slide so that we can just move on. But your watts will always be given to you depending on your appliance and the size. The watts are different. With a microwave, if you've got a very small microwave, you could use from 750 to 1,000 watts. All right, so that just depends on the size of your microwave. All right, will depend on the watts. All right. All right. So this is my example. Now, these are the appliances in my home. I've got a kettle, a toaster, and an iron. All right, I've just literally taken a picture of the watts that are at the back of my appliances. We literally have 7 minutes to go. All right, we're almost done, don't worry. Now, my kettle, if you look there, it says 1.8 liter glass kettle. It's got the model, blah, blah, blah. And then it says 2,000 watts. So my kettle, every time I boil my kettle, I'm using 2,000 watts. So my task for you today is to find an appliance in your home, all right? And you need to find how many watts that appliance is using. My toaster, all right? My toaster, it says over here, 770 to 920 watts. That's how much my toaster uses. My iron, if you look right over there, it says 1,200 watts. Now, depending on your appliances, the watts will differ. Okay, so that's just my appliances. All right. Now, my task for you is you need to find electrical appliances in your home. So I want you to please copy down this table. And what I want you to do is you're going to tell me how many watts does your electrical appliance use up in your home. I gave you just 3 options, maybe a cell phone charger, a kettle, and a television set. You can add a whole lot more. Just write down how many watts. So just looking at the previous picture, if you look underneath, it says it's got a figure and it's got a big capital letter W. So your task is to find all the electrical appliances in your home, and you are required to write down the watt for me. All right. Write down how many watts each electrical appliance uses up. All right. That is your homework. I've given you 3 that you can use. You're more than welcome to use more than that. All right. You're more than welcome to find out the kilowatts as well. Maybe if you're interested, you want to find out how many kilowatts you use in a day or in a year, you're more than welcome to do so. All right. Very quick. Basically, we need to obviously discuss how we can save electricity and how we can avoid, how can we help our parents from spending so much electricity. All right. I will just touch a bit more on this slide tomorrow. Here's some helpful links. I will also post the slide again tomorrow because it was a bit of a lengthy lesson today. Very, very lengthy. But tomorrow we're going to discuss illegal connections. All right. But we're going to start off with discussing watts. I'm going to start off by just breaking down the watts again for you. And then we will move on to illegal connections. Thank you so much for being amazing, guys. You can actually send me your work through that email that you see over there. With all your electrical appliances and your watts. Please do send through your work. Just take a picture and send me your work about your electrical appliances and how many watts you are using. All right, thank you so much, guys, for tuning in. I'm going to take the last hand. Zamili, your hand is up. Nope, you took it down. All right, cool. Guys, thank you so much for being amazing. Sorry for such a long lesson. I will see you tomorrow, same time. And goodbye. Have an awesome day.